Good evening, everyone. I'm Ray Salamanca. I'm going to be speaking on federal funding for embryonic stem cell research. According to the University of Michigan, embryonic stem cells are cells that exist only at the earliest stages of embryonic development and are capable of making any cell type in the body. Under the right conditions, these cells retain the ability to divide and make copies of themselves indefinitely. Now, former President George W. Bush had previously banned federal funding for embryonic stem cell research. However, on March 9, 2009, President Barack Obama signed Executive Order 13505, allowing funding and revoking previous decisions on this field of study. Now, to quote the President, the purpose of this order is to remove the limitations on scientific inquiry, to expand NIH, or National Institutes of Health, support for the exploration of human stem cell research, and in so doing enhance the contribution of America's scientists to important new discoveries and new therapies for the benefit of humankind. My major claim is that government funding of embryonic stem cell research will have significant benefits for society. My secondary claims include that embryonic stem cells research has been helpful in developing treatments for many diseases. Also, embryonic stem cells are more effective than any other type of stem cell. And finally, embryonic stem cell research allows the use of embryos that would have otherwise been discarded. First off, embryonic stem cell research has been helpful in creating new treatments for major diseases. An NIH stem cell, which is National Institute of Health for Stem Cell Research, states that research based on embryonic and adult stem cells has yielded promising results for the treatments of Parkinson's disease and diabetes. And according to the University of Michigan, stem cell research has also generated new knowledge about basic cell mechanisms that is critical to understanding the causes of diseases such as cancer. On a Times Online article, which is a British publication, on an experiment conducted with diabetes patients who were given stem cells. All but 2 of 15 type 1 diabetes patients were able to stop using regular insulin injections after going through the trial. Now, they were using their own marrow cells, which are adult stem cells, but it is thought that embryonic stem cells are more powerful and more effective in creating new cells. But however, the methods for extracting and isolating these and reproducing them has only been around since 1998, when Dr. James Thompson created the technique in the University of Wisconsin. Another article from Times Online talks about a study in a recent study in British hospitals where stem cells are being given to people who have suffered from heart attacks. This technique has been proven in mice using human cells, and as in Britain, healthcare is funded by the government, so this is government-funded stem cell research at work. My second claim is that embryonic stem cells are more effective than other types of stem cells. Embryonic stem cells are pluripotent, which means they can give rise to many different kinds of cells. And adult stem cell types are multipotent, which means they can only give rise to a small number of different types of cells. So, like, they can only give specific bone or muscle cell development. Non-embryonic or adult stem cells have been identified in many organs and tissues. Typically, there's a very small number of multipotent stem cells in each tissue, and these cells have a limited capacity for proliferation, thus making it difficult to generate large quantities of these cells in a laboratory. And this was from the National Institute of Health stem cell research study. However, embryonic stem cells only take 4 to 5 days to produce, Cells from these embryos can be used to create pluripotent stem cell lines, which are cell cultures that can be continuously used and can grow indefinitely in a laboratory. Finally, embryonic stem cell research allows the use of embryos that would have otherwise been just discarded. Women can, for instance, donate embryos after having abortions, if it's in an early enough stage. Otherwise, they would have just been discarded and would not have been used to help save lives. And many argue that it's unethical to use embryos, which could be potential human lives, to save another, but embryos are much too undeveloped to sustain their own life anyway, and most treatments for infertility, using like in vitro fertilization, they produce more fertilized eggs than they ultimately implant, which means they get rid of more embryos than they actually use. And in conclusion, government funding of embryonic stem cell research will have many benefits for society, since they can be used to solve many diseases, help like cure many diseases. They are more effective than other types, and finally, they provide use for something which otherwise would have been discarded.
That was pretty quick. I'd have gotten it.
Is it really your full name, or is it Raymond?
All right, Ray, you clearly state the proposition. That's fine. I like the definition that you start off with in the introduction. That's okay. You've got a good layout of the structure. You provide a little bit of background on the controversy, although that doesn't seem to be the focus of what you're talking about. The inference that you're making is that there's going to be substantial benefits, so we ought to be focusing on that. By the way, the argument that there would be substantial benefits, I'm not sure that your third point is relevant to that point. It's got something to do with we'll have access to these kinds of things, but I'm not sure it's a benefit to society. Sticking to that third point for just a second, also, I think there's something a little bit problematic, because you might be confusing the stem cells that are available from in vitro fertilization with fetuses that are aborted. I don't think that the Obama decision affects the ban on the use of fetuses from abortions for this kind of research. So that might be a little bit problematic for you. The strongest arguments have to do with particular things where there is potential benefit. The diabetes thing, for instance, though, is a little problematic, because that evidence is based on adult stem cells, not embryonic stem cells. And you say it's going to be promising, but where's the research that talks about embryonic stem cells? Now, the argument might be that it's been limited in the United States, but there haven't been limitations on embryonic stem cell research in other parts of the world. We ought to be able to see some kind of research that shows that progress has been made in those places where they've done that. And by the way, the restriction in the United States was not on the stem cell research, but only on government funding of the stem cell research. So there has been embryonic stem cell research, but it hasn't been government funding of those. So again, what kinds of progress have been made in those places? And I'm sure that there's research that talks about, I mean, you had some good evidence that it gives us insight into cell structure and how things develop. I thought that part was fine. But the stuff that applies to diseases or cures, that's the thing that needs to be developed a little bit more. The British study that talked about mice and heart attacks, you introduced it, but you didn't tell us what the results were and what the benefit was. Did it have a consequence? And I think that that was a little bit underdeveloped. Presentation, you got your hands in your pockets. That looks a little bit awkward. Sometimes the pacing is a little bit off, so you want to be more consistent there. All right, thank you.